So, your life is easy when you can get the bases to be the same. So hopefully you look at base 8 and base 4 and you understand I can rewrite them as bases of what? Bases of 2. So this is 2 cubed and 2 squared. So I still have base 8 and base 4 there, right? Say
Yes. Yeah.
what do you do with stacked exponents? Stacked exponents. You multiply them. So I have to take this 3 times 2x and this 3 times negative 1. This 2 times x and this 2 times negative 3. So now I have 2 to the 6x minus 3 and 2 to the 2x minus 6. Bases are the same. What are you going to do? So off to the side, we can set the 6x minus 3 equal to 2x minus 6 and solve that equation. I'm going to add 3 on both sides. Then I'm going to subtract 2x on both sides, and a lot of you might do all this in one step. You know, you might move the x's to one side and the constants to one side. And then the last step would be divide by 4. So my x is negative 3/4. But the key to this was we could get the bases to be the same. What makes this problem different?
Can't make the base the same.
5 and 7 are prime numbers. We can't get them to be the same. So, what we're setting up for tomorrow is working on this problem. When you can't get the base to be the same, or you want to take your exponent and bring it down in front, you can apply a logarithm. So I'm going to take the logarithm of the left-hand side, and I'm going to take the logarithm of the right-hand side. But really, I'm taking the logarithm of the base 5 and logarithm of the base 7. That allows me to bring the exponent down in front. So I now have 3x minus 1 times the logarithm of 5, 2x plus 1 times the logarithm of 7. I will tell you right now, you put your exponent in parentheses when you bring it down in front on these problems. Probably about 12 of you won't on the test, but that's okay. I said it once. I don't need to say it. Distribute. Now it's a little weird taking the natural log of 5 times things, but natural log of 5 times 3x, I don't know, there's nothing you can do except write them all next to each other. 3x times natural log of 5. Natural log of 5 times negative 1 is just negative natural log of 5. Natural log of 7 times 2x is 2x natural log of 7, and natural log of 7 times 1 is natural log of 7. Now, do you see why it's important if you can get the bases to be the same, why you should do that?
Yeah.
Because if you have to go this route, the problem becomes big. You guys will sit here and stare at this problem for a long time now. It's just like the other day in the inverse, when we tried to find an inverse, we had 2 y's in the problem, like 2 x's became 2 y's, and you guys get stuck. What do we need to do at this step? See? You divide. No. Nice try. Yeah, I mean, this is algebraic skill. What are we solving for? X. When you have things kind of now on the main row and get all of the terms that have an x to one side. So I need to move this one over here. The natural log of 5 does not have an x, so I need to send it that way. So I have 3x natural log of 5 minus 2x natural log of 7, natural log of 7 plus the natural log of 5. So remember, when you take a term from one side of the equation to the other, you can write out plus natural log of 5 plus natural log of 5, or just understand that it switches signs when it goes to the other side. What can we do now? That's right. This is the natural log of 35 over there. Why? Because I'm adding two logarithms together and have the same base. What do you do with their stuff? Multiply. What was the point of getting all the x terms to one side? What are you going to do now? I'll call in you when it's time to divide, okay? I promise I'll let you. There's an x here and an x there. So what do you do with the x in each term? Factor it out. Factor it out. So you pull the x from each term, you write it out front. What did you leave behind? Now what do?
Divide.
We will divide by 3 natural log of 5 minus 2 natural log of 7 on both sides. So I have x all by itself now. That was the key. I have the natural log of 35 on top. What is going to happen with the 3 natural log of 5? Take that 3 and put it back on the 5. What's 5 cubed? 5 times 5 times 5 is 125. Put the 2 back on the 7. What's that? Natural log of 49. What do you do when you're subtracting two logarithms? Thank you. So then I have the natural log of 125 over 49. Done. That's it.
That really stuck
That's one of those problems that now that we're done, I would almost immediately try to duplicate what we did. Like just grab a, just see if you can go through the steps now that they're really fresh in your mind, to see if you can get through it. The key is, remember at the beginning, I can't get my bases the same. So we apply a logarithm. I used ln. You could use log base 10 if you want. But that allows me to bring the exponent down in front. We do all our distribution. Get all the x terms to one side. Factor it out. Divide it off. Simplify from there.